Okay, started. Alright, let's have a little bit of review of the Z notation when we talked on Monday. Okay, so before that, no, it shouldn't look like this. View as a page. Okay. First, we need to know what is a function. Okay. So what is a function? Can anyone record that? Function.
Input mapped to an output?
Yeah. So important key feature of a function is mapping. Remember? Mapping. So you map from the domain to the range. Okay, and it has to be each. In order to be a function, you cannot have two elements from the domain mapping to you cannot have one element in the domain mapping to two different things, elements in the range, right? That's important. Okay, then what is a partial function? Based on the function. So first, partial function is a function, okay, and the partial function's domain is a subset of another set. Okay, like the partial function is mapping the natural number which less than 10 to something else. So this is a partial function because the natural number less than 10 is a subset of that natural number, right? Okay, so that is a partial function, right? And what is the injective partial function? What is injective function? Injective function means you can map from domain to the range. Also, you can do the reverse, mapping from the range to the domain. Okay, and partial injective function is the same. Partial means something related to the domain. It's a subset of something. And also it's a partial function. It's a partial function, and it is an injective function. You can reverse. And the domain is a subset of something else. Okay, so that's something about function. And there are a lot more kinds of function. For now, we are good to know this function, but there are a whole bunch of them. You can refer to the chapter 7. Yeah, the chapter 7. And if you have this textbook on the page 159, there's some symbols here which tells you how to specify different function. Here, relation is a double direction arrow, and partial function, total function, partial injection. So they all have different types of a symbol. So pay attention to that part. So it's page 159. Okay. All right. Then after we know what is a function, we learn what is a Z. So Z is basically just a set of rules. It's most widely used formal specification language. Yeah. And we use this logic. With this logic, we learn, and also the knowledge of function set and discrete mathematics to play with this specification language to specify a system. Okay, so the most basic thing is that the top level of this specification is something called a schema. Remember a schema. Okay, so under the schema we have a whole bunch of other things. Let's look at the template of a schema. Okay, so basically it has a excuse me. So this schema, it has the name, of course, and also two areas. First area is the declarations, which you can give a whole bunch of variables. You can define things such as the names, or you can define a function. Okay, a function which maps from some elements to some other elements, mapped from maybe a social security number, mapped from social security number to the name, something like that, right? And the other area is the predicates. So predicates is something you specify the pre and post conditions of the schema, right? Pre and post condition of the schema related to the pre and post conditions related to the variable you specified in the declaration area. Okay. Also, you can specify declarations of some other variable, but not in the schema as well. And then let's look back a little bit on the Social Security directory. Let's look at the whole thing. Okay, this is how you define that variable, specify that variable. Okay, let's go back here. So Social Security directory, basically you have a number, a set of names, and you have function mapped from the Social Security number to the entry name. So the function can be different, can be just a function, or you can specify it as partial function or injective function, something like that. But it depends on what is the logic in the system you are specifying. Okay. So, and here, since we are defining this number as a set of Social Security number, and this has not been defined anywhere yet, so we can use this kind of format here. This is not a schema. It's just something you can use to specify this variable, this type, like Social Security number. It's a natural language. Yeah, it's a natural number, and the range from 1000 to 99999, things like that. And entry name is a sequence of char, something like that. Okay. And then this is this is a very first, complete example of the Z schema. You see, it has three variables, three members in this declarations. So three variables. First, we have a delta schema. We have a delta there. So that means this operation is gonna change the Social Security directory. Okay, you remember, delta denotes this operation changes the state of this variable. Okay, and then we have question mark there, which means, so remember, input, right? It's an input. Okay, so the question mark is the input value. And so we have input of number, we have input of name. So this operation of insert new Social Security entry, basically what it does is, first you have to ensure that number doesn't belong to that domain. So whatever you want to insert is not there. Therefore, you can insert it to the old set, okay, old mapping. Then whatever you do is that post condition. After this execution, the post condition is the Social Security direct prime equal to the old Social Security direct union this new map from the number to the name. It's a map from the two input. Okay, so that's basically the logic, the format there. It shouldn't be very hard, but sometimes you just need more practice on this. And var, variable question mark, means input. Exclamation means output. Yeah, precondition, post condition. Also, we learned another symbol. It's called overriding. A difference between overriding and the insert is insert just you have to ensure that something is not there. But override, you don't have to ensure it's not there. If it's there, you replace it. If it's not there, you insert it. Okay. So this thing is more, it's just about the logic there. And the domain subtraction operator. We learned that, okay. It's you subtract something from that domain. You subtract that mapping from this function. Okay, like this new phone function is mapping from different names to the phone number, and you use this domain subtraction to subtract one of the mapping from it. Okay, you just need to specify that mapping by specify its elements in that domain of that relation. Okay. Alright, so that's what we learned last class. And let's talk a little bit more about the Z. Whatever you can do is that some additional Z features I'd like you to know here. Okay, first is the relations as a set of ordered pairs. Okay, so what is the relation? I think we talked about that. So it's a set of ordered pairs. An ordered pair is a pair of items which have the property. So this is basically a formal definition of that. But an ordered pair means you cannot just swap the order of the first element and the second element. Yeah. And this kind of specification actually ensure that you do not swap the order. That's a relation. Let's skip this part. Okay, relation restriction is we know what is the subtraction, and the domain restriction operator is similar to the subtraction operator. They both restrict the domain of relation instead of restrict the range. Okay, so the domain subtraction operator is whatever we did. So we subtract one element and its mapping from these relations, right? Yeah, and the restriction raptor restrict the domain of a relation by identifying those elements that are specified. So whatever you want, you specify them. Let's give an example here. Okay. So this is connected. It's a relation. Okay, from here. React 1 to monitor 1, React 2 to monitor 2, those relations, okay? Those relations. And if we are trying to do something like this, we restrict is connected, this whole set of relations, by these two elements. Okay, what happened is, if it is subtraction, whatever subtraction, if it is subtraction, it means we will remove whatever included reactor 1 and reactor 2, whatever relation includes reaction 1 and reactor 2. So we just remove this, right? That's it. However, if it's restriction instead of subtraction, it's the opposite. We just remove everything else, and by only keeping whatever relations that have a reactor 1 and reactor 2. Okay, so that's clear. The difference between subtraction and restriction.
Can you specify domain and range in this?
Okay, so here, you may be a little bit confused. That's okay. So here, it's connected. It's a relation, right? Over the reactors by the monitors. The domain of is connected means the set consists of the first element. So here the domain of is connected is reactor 1, reactor 2, cracker 1, cracker 2, cracker 3, distill 1, distill 2. Okay. So there's no duplicate elements there. Remember that? Okay. And the range of is connected is monitor 1, monitor 2, monitor 3, monitor 4.
Wait, isn't distill 1 connected to two different outputs?
Distill 1, distill 2. Yes. So here, see, it's connected. It's a relation, not a function.
Okay.
Okay. So a function is the relation, but it's more restricted relation. You have only one mapping there. Okay. But relation, you can just put anything there. Yeah. And you can even restrict the function, like injective function, partial function, which have more conditions that you have to meet. But relations is just a pair there.
Okay.
Order the pair. A whole bunch of pairs. Okay. All right. So this restriction, you apply it to, you can apply it to a relation. So you can apply it to a relation, so you can apply it to a function, right? Because function basically is a relation, but it's more specific relation. I meet some other conditions. So, but function is a relation. However, this so this thing can be applied to a relation, or so it can be applied to a function. Okay. So this is a restriction, like restricted. So sometimes you want to maybe restrict the function to accept only certain types of input, right? So this might be helpful when you're trying to specify that kind of thing, right? Make sense? Cool. Okay. And then here, another example here. Distill 3. We restrict is connected. By distill 3, we got empty set because we do not have any relation of distill 3, right? So if we restricted it by distill 3, we got nothing out of it. Okay. Okay, then it's a reversed, something tricky. It's a range restriction operator. This is called domain restriction operator. The tip is to the left, right? Because domain is the left element. And then range is the right element. Okay, so this symbol here has this tip to the right. Okay, the similar operator range restriction operator, a triangle to the right, which restricts the range of a relation. So you should be able to infer what does that mean. So if we restrict the range of is connected, this relation, mean name is connected. We range it with monitor 1 and the monitor 4. So what it does, it will only give you something. It will extract a subset from that relation, and the subset only contains the monitor 1 and the monitor 4 as its range element. So it's something like React 1 to monitor 1, Cracker 2 to monitor 1. If you have a Crack 2 to monitor 3, then that's wrong. It's not the result returned by this restriction. Okay. So all those are our simple logic. You understand that pretty quickly. However, it takes your time to memorize. After you memorize, you understand, you memorize, then you will know how to use them. So you need to take time after class to try to review this material, memorize them, and apply them in the exercises. So that's important. So like this, restrict the range. It's pretty easy, but somehow if you're not reviewing this material, tomorrow when I gave you this triangle, you will know, you already forgot, right? You think that's maybe a delta, something. Why it's a delta? Okay. Okay, this set difference, we already talked about it. It's just when you will subtract something from that. So we will not repeat it. Okay, let's go to Z. So Z has another facility that allows the specifier to declare the sets which are basic types in specification, those sets which are assumed to exist that can be used in specifications and do not require any further definition. So yeah, within the square brackets, so you can just define the set, but you do not need to further information of that. Just a set of cars or a set of parts, those things. So this declares, so this set and the spare parts, that declare two sets used in the spare parts warehouse application. And if you want to use them in your application, you can define like students, instructors, classrooms, just a set of them. If you want to use the set, you can just define them here. Yeah, another facility allows you to specify the a set with a small number of members, right? Just like you enumerate all the members of a set. Yeah, and you separate each of the members. So it's a colon equal, something like this. So if you want to use cars, so this is the cars spare parts. So to the situation when you are modeling a system, okay, you may have some set that you do not know the members of it at all, because it may change, may dynamically, like this cars. You have new inventory, you sold some cars, the inventory change, so you do not have to specify I have car 1, car 2, car 3. You do not have to do that. However, in some other system, yeah, you might want to specify maybe a set of cars that owned by somebody, right? Owned by a person or owned by some organization. So that organization have 4 cars and they happen to be different brand or car brand. So if you want to specify that, that's fixed. Okay, that set is fixed in your system, like static variables. If I refer to that, it'll be easier to understand. Like static variables or the cars. If you want to specify each element there, you can use this column equal. So E is specify each of the elements of that set. Okay, so that's two different situations. One situation is you specify a set that you do not know what is inside in the system. It changed dynamically. And then you want to specify here you want to specify like owners. In the system we have only these 5 owners. Right? Owners do not change. If that is the assumption of your system, you can specify a set this way. Okay. Like direction. Like if you want to specify hands, you just need to specify left hand and right hand. Right? But if you want to specify, if the hand you defined is the hands of all the students, maybe you do not want to specify that, each element of it. Okay, so you can specify a dynamic set, you can specify a maybe static set here. Okay. Also, global constant, we use that a lot in our system, right? Like pi or 3.14, something like that, right? So that can be specified with this double equal, with 2 equal symbol. Okay, like the maximum amount of a student in a class, you can specify it this way. Okay. All right. And what is called schema inclusion? So this means by which schema can be referred to by other schema. So you are using a schema from another schema. Here's an example. The following schema set inventory. When it's required by another schema, it's written in the signature part of the schema that requires it. So mid inventory refers to the upper and the lower schema use set inventory. Okay, set inventory. Okay, so set inventory, the top one. Let me put it. Okay, so we have first schema, which is set inventory, right? You have upper inventory, lower inventory, the set of nature number. You have a max size, and the restriction there is the precondition there. Maybe there's no post condition here at all. So the number of upper and the number of lower, the sum of it, should be less or equal to the max. Should not be larger than the max size. Makes sense, right? So that's set inventory. You set that inventory. And here we have another schema which is trying to use this set inventory. So what you want to use is it want to use the upper and lower maybe and the max size of it in this schema as well. So you can just refer to that set inventory and put that schema as a member, as a variable here in mid inventory's schema. Okay, and you have your own middle inventory is included in the upper union the lower. So that's basically because you're using the upper and lower and you do not want to redefine them again, so you can just refer to wherever you already defined that. Right? It's like when you are using a class, you're referring to the other class as a member of that class. Something similar to that. So this kind of combined this middle inf include the set inf. So basically it's a conjoin of the predicates and the signatures. So it's the same to write this way. If you're not referring, include that schema. If you're not using schema inclusion, you can write it this way. Like you define middle, and you redefine this upper level again. You redefine this max size again, okay? And then you put, or you combine those different predicates from both schemas, right? So this basically, the third schema basically is the combination of first schema and the second schema. Okay, that's something called schema inclusion. So it's a way to help you to write the specification. Okay. All right, let's go back a little bit. So declare sets, right? Two different ways, and declare and use this schema inclusion. And here, two more operators, restriction operators. We can restrict the range. Also, we can restrict the domain. Also, we can restrict the range. It's just different direction, triangle. Okay. Okay. So basically, that's each single part. It doesn't sound very complicated, but if you want to try to combine them, you will meet some problem when you're trying to combine them. So the best practice is to trying to do that and expose the problem, and then we fix the problem. So here, let's try some exercises here. Okay, two of them. First, let's try this first one. Okay, so let's try this first one. Let me explain it a little bit. So you need to write down a schema. The name of schema is course. Okay, so there are three variables in the course. So the first is the instructor name, which is a sequence of character, and the student name, that is a set of names of the student. Okay, and the partial function GPA, which maps the students. It shouldn't be GPA. Let me. Great. And you have in this schema you have three variables: first, second, and second. Third is partial function grade, which maps student names to his or her grade in this course. Okay, so please specify also please write down this schema, and also specify any post and preconditions as predicates which you think is necessary for this schema. Okay, so I am not explicitly specify any post and precondition, but that's not. Larger. Okay, let's do this first. Let's have 10 minutes to work on this first. Okay, anything unclear about it? It's not on the book. The first one is not on the book. So.
That's fine.
So remember the schema, the format of the schema. Okay, I'm going to pick up a pen, and I'll come back. So let's have a 2-minute exercise. Alright. I think you finished the first question only. Okay, so let's move here to this whiteboard area. I need a volunteer to write down your answer to the first one. Okay. Laura?
I'm not finished.
Okay. Who finished? Just the first one. It's okay, it's okay.
Alright, I'll go.
Someone can make everything right. That's the first try, right? It's always first try. Instruction. Grade is a partial function. Anything you think should be the maybe the preconditions, postconditions, those are predicates. Okay, so finish?
I think so.
Yeah, okay. Let's try.
Go back.
Okay. First, let's look back here. Format. If you look back at the Z note, let's look at the example. So this is actually something looks like this dash, right? So if you want a complete schema, so you have to have all the format there, right? So in this question, I specify that the schema actually has a name, means course, right? So we want to include that in the format. So like here, we want to put the course here. Okay. So first, if you want to specify as input variable, you are using the instructor name. Okay, so basically you will, if you want to do this way, you will need this column there, right? This column there. And here, if you want to specify this as input, and to specify this map. So actually, you don't need this brackets here. Just in this column here, and this is correct. This is a partial function. That's all. And if I'd like to write this specification, first. Yeah. Okay. Okay. So the first variable says the instructor name is a sequence of characters. Right? So we'd like to specify that sequence of characters, and I don't think we it's necessary to specify as an input. Maybe it's in some other situation, but here we're not like doing that operation, taking an input and doing something else. Right? So we don't need this question mark here. And instruction name. Instruction name. We specify whatever in that question. So it's a sequence of characters. And student's name. Student names is a set of names, right? We need to capture every details of the system so that we can specify that system, convert the system to this completely to this schema. Okay, so student names, and it's not necessary to specify it as an input, so we just say it's a set. It's a set of names of the student. Okay, so just say it's a set. We can assume that it's also a sequence of characters. Okay, and grade is actually a function. So this is correct. You're mapping from this. Okay, here, let's. Just say students' names. Okay, so this is student name. If you want, you can have some other scheme, some other thing here that specifies some restriction to this student name, like how many chairs here to be less equal. What's the question?
So wait, why did we say that that was student name, but instructor is sequence of characters?
So this is not like the fixed answer there. We can see it's also a set.
So it can be either.
It can be a set of sequence of chair, or we can say it's a set of student name, and then we can have some other place we specify what is student name. So it's a sequence of chair, and the number of chair is less than maybe 50, something like this. Right? Let me just this is an example. Okay. Here. and you want to put some explanation to student name, you can put it there as something else. Or you can just say here is a set of sequence of chair. So it's okay. Okay, and then grade is a mapping from actually the student name to the mapping from student name to this grade. Actually, grade, if we are using grade here, we kind of want to define that as well, right? Because what is grade? So grade is something like between A and F. A, B, C, D, F, right? A, B, C, D, F. So we want to specify grade somewhere. Something like that. Okay, so it's a partial mapping from student name to a grade. Okay, so this part looks fine, and you might want to have some extension there. It depends on how you want to write it. But the important thing is you do not use anything out of nowhere. Like here, if you just want to specify a grade, maybe you want some definition of the grade in order to reduce the confusion. Okay, so full specification is like another way of express some meaning, like something you expressed before with the natural language, but now we are using this way. Okay? So like when you are speaking, when you are talking, you have different ways. So when you're using full specification, there could be some possible solutions there, not like fixed. Okay. But there should be some principles there. Okay, and then here the students belongs to grade. Maybe we don't need this. And we can specify this instructor name. Greater or equal to 1. That's fine. And you may specify something else, like I don't know what else. Instructor names, student names. Okay, so that's a set, right? And we can have this, right? Number of student names. Number of student names. So that means this set, the length of this set, right? Like how many students. So length of student names means how many students is in that course, enrolled in that course, right? So there should be a limit, right? Usually we have a 30 or something in one course, in one session of the course, right? So it should be, let's assume 30. Yeah, something like that. Anyway, but this is not specified in that part. If you think that it's necessary, you may want to put that assumption here. So this is like kind of like your assumption, your own assumption, because this thing doesn't exist in the system specification. So when you specify it, you kind of want some assumption there. Okay, so that's the first one. The second one is a little bit harder. Let's try the second one. Let me move it up. Okay, so from number 2. So the first paragraph is a natural language, a paragraph from extract from a specification of a system, and then the second paragraph is the requirements of what I want you to do. What I want you to do is in this specification, model by that with a function named stores, and the function occupies, and a schema, which is equivalent to this number 2 description. Okay. So one thing is you have to extract information from the description and make a specification according to the requirements. So it's just like there will never be more than 30 users of the system who currently own files. No user is allowed to own more than 25 files, and no file is allowed to be bigger than 500 blocks. That's a whole bunch of restrictions there. Maybe you consider put them in the predicates, pre-post condition, like this area. Okay, let's think about it for 2 minutes, then I will just write down the answer. And that description doesn't give you anything like the name of the schema, right? So we can give a name here. So size schema. First, let's look at the variables there. First is modeled by a function stores, right? So we should have a function. And let's read that it's a mapping from the user name to a set of file names. Setup is using this P. Right, and then we keep reading, and the function occupies, which relate the file name to the set of numbers which represent the block that the fires occupy. Okay. Occupy. Which maps from the fire names to a set of natural numbers which represent something, right? Represents the block that the fires occupy. So this. So that's two functions. So this is like a domain and range. Domain and range, right? So two functions. First is stores. The username is mapping to the fire names. So you give a username. Then you have the fire name, then user own. Okay. Okay. And then we put some here in this area. We'll put some restrictions to that. First, it's specified that there will never be more than 30 users of the fire system who currently owns fires. No more than 30 users, right? So we have usernames here. Usernames here. So actually usernames is the domain of the stores, right? It's because the stores is mapping from username to the fire name, so the domain. So first we will want to specify the number of users. So the number of users basically is the numbers of the elements in the domain of stores, right? So it's going to be number of domain. Less than equal to 30, right? And then, right, no user is allowed to own more than 25 files. So user and files. How can we specify that?
Range.
Yeah, that's basically you use range. You can have those file names, but you need to associate that with the username, so that actually here we're going to use this function a little bit in the format here. So here, after writing out, we will understand that's something that we want to memorize. For all the name that is here, for all the users, which here basically means for all the users, okay? For all the users, that the number of stores so here, maybe this part is a little bit confusing. Because if you remember, this stores is a function. Function basically is a relation, right? It's a relation. So when you are basically means specifies when you give this a number to this relations. Okay, then the output from this function, the amount of the output should be less or equal to 25. So if this is not clear, we can do this way. We can do it another way. If you remember, this thing? What is this thing? Restriction, right? Only by for all the names here. So that just means for all the users, okay, it cannot own more than 25 files. And because we restricted the source. The source basically is beside all the users. Okay, and for each of them, so we give this for each of them, it should be less than 25. Okay. And then the last thing here. No file is allowed to be bigger than 500 blocks. So 500 blocks. Blocks is specified here. That's occupied. So we'll do some similar to here, to this name. So for all the file belongs to the domain of occupies. Such that the number of because this occupies mapping the file to its blocks, right? To its blocks, to the number of blocks. So here we specify for everything that's in its domain, which means all the files in the system. If we restrict the function to all the files in the system, and for each of them, it should be mapped to a negative number that is less than 500. So it's similar to the solution here, right? I'm using this restriction to make it maybe a little bit easier to understand. Okay. All right. So yeah, it might be a little bit hard to get everything on track and to write this directly. So you just need to look at more examples on the book and try to read and then form your own style of writing this specification. As I mentioned, actually there are a whole bunch of different ways to specify something. Just you may find some ways better, some ways not that good. You need to form your own style if you are going to write this, okay? And if you are turning your assignments or this test exam, yeah, as long as I can see the restriction, the logic there, then it should be fine, okay? You do not have to like restrict yourself to only some certain solutions, because there's no specific solution that for one question. There's plenty of solutions. Okay, all right, so that's it for today. Thank you very much and have a nice spring break next week.